Hello, we're going to look at an example of integration by substitution involving a little bit of trig. So we need to have our trig identities at hand for us. But let's start off by using the substitution, which is going to be u equals tan x. So in this instance, you'd be given that, which is somewhat of a relief. Du dx is sec squared x. So tan integrates to, differentiates to sec squared x. Nice little bit of magic. Rearranging gives us dx is du over sec squared x. Something else important here is we have limits. Those limits are in terms of x. We have x equals 0 and x equals pi over 4. So I really want those in terms of u for when I change the variable. I'm changing from x to u. So when tan of 0, u is 0, so that's a nice one. Tan of pi over 4, or tan of 45 degrees, if we're thinking in degrees, is 1. So we've got quite nice limits there. Let's do some substituting now. I'm going to rewrite my integral. I'm going to be bold and I'm going to write 1 and 0 there, because we're now in terms of u. I'm just going to keep sec to the power 4 x there for now, times root of u. Now dx is of course du over sec squared x. Well, as you can see, I've got sec to the power 4, sec squared. That's sec squared squared, so we're going to get a bit of cancelling out here. Sec squared x, root u, du. Okay, yeah, there's still a bit of a problem. We're still left with sec squared. We don't like it, do we? We don't like it one bit because it's getting in the way of doing the final integral. But we have a think back. I know tan squared x plus 1 equals sec squared x. Now that's pretty useful because sec squared x, using our substitution, would be u squared plus 1. So I can put that substitution in there now. U squared plus 1 times root u. Let's call that u to the half now. I want to get that ready to integrate. Now, we've done a lot of the hard work there, really. We've changed the limits and we've got everything in terms of u. I'm going to expand this bracket, so u squared times u to the half. So that's 2.5, 5 over 2. U to the 5 over 2 plus u to the half du. And let's move it up a bit so you can actually see. Now we're going to do some integrating here. So that's going to be u to the 7 over 2, 2/7, plus u to the 3 over 2, 2/3. And now the fun bit, we get to do our substituting. Let's see how this goes. Well, because 0 is one of the limits, and with this type of function it's just 0. And then we've got 2 over 7 times 1 plus 2/3. Well, let's have a look at this. What do we get? 21. So multiply that by 3. So we've got 6 over 21. Multiply that by 7, 14. And that gives me 20 over 21 as the final answer. So that's a reasonably demanding problem there because of what's involved. The understanding of trig identities, the application of the integration by substitution. You've got the actual definite integral substitution at the end. There's lots of ways to go wrong, so you've got to keep your wits about you, concentrate, keep doing the right thing. I hope that's useful, and my advice is to go and practice hundreds of those.